We're now going to look at the properties of exponents, which is also called the laws of exponents. So I'm just quickly going to run down all the different rules that we have for exponential expressions. How we can reduce things, what we do with negative exponents, what do we do when there's a product, when there's a quotient, when there's an exponent of 0, when we have negative exponents, we have power to a power, when we need to expand, and those kinds of things. So I'm going to start off with the power to a power rule. And with the power to a power rule means that you've got an exponential expression, like we do here, 3 squared, and the entire expression is raised to another power. So I've got 3 squared raised to the 3rd power. Now what you do in this situation is you multiply the exponents. So 3 squared to the 3rd power means I'm going to multiply the 2 and the 3. So 3 to the 2 times 3, which is 3 to the 6th. Now why do we do this? If I were to actually expand this out, 3 squared to the 3rd power, what I'm actually doing, and I'll write that up here, is 3 squared times 3 squared times 3 squared. That's 3 times 3 times 3 times 3 times 3 times 3. That gives you 3 to the 6th. That's 6 threes. So that's why the rule works. So let's look at our first one. Our first example, I have x to the 6th to the 5th power. It's a power raised to a power, so we're going to use the product, and we're going to multiply the 2 exponents. So x to the 6th raised to the 5th would be x to the 6 times 5, which would give us x to the 30th. And that is your answer. Again, if you want to know why it is that way, this is the same as taking x to the 6th 5 times. If I were to expand it out that way, I would see that I have 6, 6, 6, 6, and 6. I've got 30 x's there. So let's come over to number 2. I've got 9 squared raised to the negative 3rd power. And we're going to get into negative exponents next. So if I raise this, again, it's a power raised to a power. It's a product. So 2 times negative 3, you keep the signs intact. So that would give you 9 to the 2 times negative 3, which in turn gives you 9 to the negative 6th. And we're going to leave this here, and we're going to come back to it. So let's drop down and look at that negative exponents. Negative exponents. Negative exponents basically means if you've got a fractional expression, if you've got a rational expression, meaning it's in fractional form, when you have a negative exponent, if you want to make that exponent positive, you move the term, the entire term, the base and the exponent, to the other portion of the fraction. As you remember, every fraction has a numerator, which is your top value, and it has a denominator, which is your bottom value. So when I have negative exponents, I'm basically going to be moving the terms back and forth between the numerator and the denominator. And if I take a positive exponent from one and move it to the other, it becomes a negative exponent, and vice versa. So let's look at this example. I have 5 to the negative 3. Since there are no numbers on top, this is the numerator. It's the same thing as 5 to the negative 3 over 1. We always assume we can put things over 1. If I want to make that exponent positive, I'm going to take that 5 to the negative 3rd, and I'm going to move it from the numerator down to the denominator. And when I move that term from the numerator to the denominator, I'm left with a 1 up top, because when you move everything, you're just left with a 1, and that exponent becomes positive. Let's look at another example. Now I have 1 over 2 to the negative 6th. Again, if I want to make the exponent positive, I move it from one part of the fraction to the other. So if it's in the denominator, I'm going to move it to the numerator. So the 2 to the negative 6th goes from the denominator, up top to the numerator, and we now have a positive exponent. So let's look at these examples. Write the following using exponents. Okay. And I should have said exponents or positive exponents. We'll be a little more specific just to see if you know how to manipulate these. So let's start with 1/8. Okay. 8 can be written as 1 over 2 to the 3rd. Okay, so there's our positive exponent. We're pretty much done. If I didn't want to use the positive exponent and I wanted to use a negative exponent, and let's say I tried to eliminate the fraction, I could also write this as 2 to the negative third. Remember, either one of these will work because if I have the positive exponent in the numerator, it becomes negative to put it, in the denominator, it becomes negative to put it in the numerator. So let's look at another example. I've got 4 to the negative third in my numerator and x in my denominator. So let's make that positive. So I'm going to move the 4 to the negative third down to the bottom. That's going to leave me with a 1 only on top, because it's essentially what you're doing is you're dividing. And then I'm going to have 4 to the positive third times x in my denominator. And at that point, I'm going to actually go ahead and multiply this out. 4 cubed is 64. So it's 1 over 64x. This would also be acceptable because we have I asked you to write it as exponents. But if you want to actually simplify it as much as you can, you've got 1 over 64x. So let's look at the last one. I've got y to the negative 2 in my numerator and x to the negative 3 in my denominator. So if I want to make these positive, I just move each term to the opposite part of the fraction. So I'm going to move the x to the negative third up to the numerator, and it becomes a positive. And I'm going to move the y to the negative 2 down to the denominator, and it becomes a positive. And I'm done.